Hi everyone. In this video we will study on irrational numbers, an introduction to irrational numbers. To develop a better understanding on irrational numbers, we will start from the numbers which are not irrational. I mean rational numbers. As you know, two important roles of numbers in mathematics are counting and measuring. The counting role, for the counting role of the numbers, whole numbers are sufficient. 1, 2, 3, 4. 1 cow, 2 cows, 3 cows, 4 cows, maybe. But when you start to measure, the whole numbers are not sufficient. To fill this insufficiency, let's work on some measurement tasks. Of course, you can work on real environment with real subjects. Maybe you can measure your desk's length, but I prepare some figures on GeoGebra for you. Let's measure some property of these shapes. For example, radius of the circle is 2 units. Whole numbers again worked. Let's measure the radius of this circle. Now the whole numbers are not sufficient. Of course, at this time, how can we understand the length of the radius of this circle? We will use a special approach coming from the history of mathematics. We need to divide the two numbers into equal parts. I prepared a custom tool for dividing equal parts. How many equal parts? Let's try 2. Oh, 2 part doesn't work. Let's try another. Let's try another partition number. Okay, what about 3? What about 3? Sorry. Oh, 3 also didn't work. Let's try another number of partition. What about 4? 4 also didn't work. Sorry. What about 5? Ah, 5. I see that 5 is okay. Let's make a zoom. Okay. The radius of this circle is 1 and 3/5 units. We understood that the radius of this circle is 1 plus 3/5. 1 plus 3/5 unit. How did we understand 3 over 5? Because one complete unit and 3 times 1 over 5 unit also exist. Let's try to measure other lengths, the length of KL. Now we need to understand how much is here. Now I need to divide the points 2 and 3 into equal parts again. What about 3? 3 didn't work. And what about 7, for example? 7 also didn't work. Let's by this way. Okay, let me go fast. By this way, you can find this application, this dynamic application, on my GeoGebra tube profile. I will give the link and explanation of video. Please measure this length and this length by using this custom tool. How this custom tool can be used. Just select this custom tool, then select 2 points, then enter the number of parts. For example, if you want to divide interval of these 2 number, just click 2 number, then enter the desired number of partition. To go back, just select the partition, just select the partition and delete them. Now I will try to measure the diagonal of this square. I prepared the square before. As you know, as you see, the diagonal is between 1 and 2. 1 plus how much unit? I don't know. Let's try. Maybe 5 may work. Oh, thankfully GeoGebra has great potential of zooming, but when I zoom in, I saw that 5 partition didn't work. Let's delete the partition and try another number of partition. Let's try maybe 9. Didn't work. Again, didn't work. I will mention how I created this custom tool in another video. Number of the partition, the 15 partition also didn't work. At this time, let me use another more fluent application. Okay, this will help fluently. I created a square here whose one side is 1 unit, and by using this circle, by using a compass, I carried the length of the diagonal on the number line, and I am trying to measure it by using this slider. This is a more fluent previous application. As you see, I catched a number of partition 5 here, but when I zoom in, the number of partition didn't work. Then trying to find another number of partition, the 12 partition, 12 equal part, I think maybe may worked. I don't know. The diagonal, the length of the diagonal is 1 and 1, 2, 3, 4, 5. 5 times 1 over 12. Maybe. Let's zoom in. When I zoom in, I saw that the 12 partitions also didn't work. Is not sufficient to measure the diagonal of the square. Let's go on searching. Let's go on searching. 29 partitions, I think, is okay. The diagonal, the length of the diagonal is 1 unit plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 1 over 29 times 1 over 12. Maybe. Let's zoom in. 29 partition also didn't work. Also is not sufficient to measure the diagonal of a square. Let's go on to increase the number of partition. My slider is just restricted by 50. I can also increase it and go on to search. Let's see whether we can find a suitable partition or not. 70 partition did work. Let's see. No, 70 partition also didn't work to measure the diagonal of the square. Of course, you may work in a real environment, I said at the beginning of the video, but the part of this task, this point, you cannot use a real ruler, because when you use a real ruler, maybe you estimate, yes, I measured the diagonal, but thanks to this dynamic application, I can change the partitions of the ruler quickly. You can assume that this is a dynamic ruler, and I can make great zooming to understand any of the partition didn't work. So this is a strong intuition that some lengths cannot be measured by rational numbers. Maybe we need new numbers, and Of course, you know that by the Pythagorean theorem, the by the Pythagorean theorem, this length is the number whose square is 2, and the number whose square is 2 is not a rational number, which can be stated by the two integers ratio, and we need to show this number just with a special symbol, just which is a special symbol like this, square root of 2. Thank you very much for watching. I hope this will be useful.